All right, so this is Stephen Chin for our Night Hacking JFocus interviews, and today I'm going to be interviewing Eric Romner about his Raspberry Pi performance testing wall.
Thank you.
So tell us a little bit about what your motivation for this this project was.
Well, actually, we were working with a customer, and we were building a network server.
Mm-hmm.
And the server had very high requirements for uptime. It was to be up basically all the time. It also had high requirements for performance. We needed to support 50,000 concurrent network connections to it. And we also needed to handle 100 business transactions per second at a sustained rate. And we were also using SSL, so there were SSL handshakes going on in that time as well. And the server used a combination of a custom binary protocol and SOAP. Also, there were very strict security requirements.
So you couldn't just outsource it to a cloud service like Amazon?
Exactly. So we needed to ensure that things were tested. And we thought about the usual alternatives. We thought about using a single server, dedicated server, about using the developer workstations, setting them up using Grindr or some other framework. We also thought about using the cloud, but as you said, the security requirements were quite strict, so we couldn't get the cloud in through the firewalls. Also, we wanted to run sustained tests for very long times, and with the cloud, that would actually have been quite expensive.
Yeah.
So finally, I thought about buying cheap Raspberry Pi computers and setting them up on a wall and using them to run the tests.
Cool. And how has this worked out for you?
It's worked out very well, actually. The key thing to think of is to keep costs down, because the Raspberry Pi itself is very cheap.
Yeah.
But when you start to add all the peripherals you need, it adds up. So what we did was we bought Raspberries for about $25 a piece, and then we soldered them directly to a power supply, so we didn't have to buy USB power cables.
Okay, so it's a little cost savings there.
Yeah, and we bought memory cards, network cables, and then the important thing as well is to find a cheap switch, because if you buy a really small switch, you will get it for nothing. But as you add more units, you need larger and larger switches, and eventually you end up with an enterprise price tag switch.
Yes, that's true.
So you need to find a balance, as many Raspberries as possible before you get to the enterprise switch level. And it turns out that the largest switch you can buy...
What's the magic number?
Is 48.
48.
48 Raspberries. So both our wall and the Hazelcast supercomputer with Raspberries both use the same model of switch, actually.
Okay.
So that's that, and we ended up at about $3,000 for 48 units.
So that's, I mean, as far as corporate performance testing clusters, that's a pretty good price tag.
Yeah.
So you're going to put your markup on this and sell this at the show now?
No, but I know of at least one company, I don't remember the name, but they have copied the solution and built a wall themselves.
Oh, very nice.
So in that respect, I think it will stick around. One of the choices we had to make was which Java version we were to use, because at the time we did this, the Java SE 8 embedded was still in early release. It was not legal to use it. Java SE 7 embedded was usable, but it required a license, and it also only supported soft floats on the Raspberry. OpenJDK was free and supported hard floats, but as you can see in the chart here, it is much slower.
Yeah.
But in September last year, Oracle actually released their JDK for Raspbian, so now we can use the real thing.
Cool.
And I brought the travel wall with me here to look at. If you could
so we have
zoom in a bit.
demos.
Some hardware. Like this.
All right, so tell us a little bit about what's going on your hardware board here.
Yes, down here we have the power supply.
Okay.
It's on the first version we built, we had a PC power supply that could handle about 35 units. This one is much smaller, and since I will be lugging this thing around, it was worth the money.
You want something travel-worthy.
Yeah. And this is a very cheap consumer switch. We have connected the power supply both to the switch and to a connection board here, where we have small thin power cables going to the Raspberries, where we have soldered them on the behind them. And yeah, then we have the Raspberries themselves screwed onto the wooden panel.
Cool.
So it's a fairly simple design.
So any special considerations when you're trying to route power to multiple Raspberry Pis like this?
On the small wall, it's not anything to think of, really. I wanted to be able to take off the Raspberries, because when I was traveling to the United States with this one, I didn't dare send it in the checked-in luggage. I took the Raspberries in my hand luggage. So I wanted to be able to detach them by simply plugging them off like this.
Nice.
But on the real big wall,
they're just
we
hard
have
soldered on them.
Yeah. The big wall, we have thin cables, and then we connect them to thicker cables before going to the actual power supply.
Okay.
Otherwise, nothing to think of, really.
Cool.
And yeah, we got the results we wanted. We were able to run sustained load tests for several weeks, and all that time we had about 90,000 concurrent connections and 100 business transactions per second.
Nice,
so
nice.
So quite a lot of load.
Yeah, and this is not something, I mean, you homebrewed a solution with Raspberry Pis, but if you had to buy an enterprise-grade solution for this sort of load testing, what would it have cost you?
I don't know, but I can say that we looked at using Amazon Cloud, and they wanted about $16,000 per month for this kind of performance.
Wow.
So $3,000, and we can run it for as long as we want, is much cheaper.
No, that's very cool. All right, so in closing, how do people find out more about the Raspberry Pi wall?
Well, they can always go to my blog, and they can, if you just search for Raspberry Pi and CodeMint or Raspberry Wall, I'm sure it will show up there. And they can listen to my talk tomorrow at 3:30 here at JFocus.
Cool. All right. Thank you very much, and hope you enjoy the rest of the conference.
Thank you.